today we're going to be learning how to model with linear systems, which is something that we have been building up to in this whole unit. We looked at solving linear systems using substitution, elimination, and graphing, also solving linear systems of linear inequalities by graphing. And so now we're just kind of taking these skills that we have and we're going to use them to actually solve real world problems and determine the best method to solve the system using all of the skills that we got. So let's just go ahead and jump into it. Our first example is we're going to write a system of linear equations that represent the situation, and then we're going to solve the system. So in this example, Bobby is buying coffee and hot cocoa for his class, which would be really nice. Each cup of coffee costs $2.25, and each cup of hot cocoa costs $1.50. If he pays a total of $15.75 for 8 cups, how much of each did he buy? So to solve this, we're going to create a table. This isn't like an input-output table. This is really kind of like the verbal expression. We're just going to put it in table form so that way we can see patterns start to emerge. So cups of coffee, we're going to represent by the variable C. This makes sense because C is for coffee. And then hot cocoa, we're going to represent by H. Okay. And I know that the number of cups, if I add C and H, that's going to equal 8, right? Because Bobby bought 8 cups of coffee. Apparently he didn't buy it for the whole class. He only bought it for his cohort. So then now the cost of cups of coffee are going to be represented by 225C, right? Because it's 225 per cup. And the cups of hot cocoa is going to be represented by 1.50H, because again, it's $1.50 for each cup of hot cocoa. And then if I add those two together, then I'm going to end up with my equation, with my total, which is $15.75. That's how much Bobby spent on the drinks today. So what's really cool about this table is you can see the equation. It's C plus H equals 8 and 225C plus 150H equals 1575. So let's go ahead and write our linear system. So we're just, again, taking our linear system from the table we created and regurgitating it in the form of an equation. So C plus H equals 8. I did switch to the lowercase h just because in the equation tool it looks awesome. And then the other equation that we have is 225C plus 150H equals 1575. Alrighty. So now that I have my two systems, this is something that I can solve using either substitution or elimination. And so actually what I'm going to use is I'm going to solve using substitution because I already have a variable isolated. To get the variable completely isolated, like say C, I'm just going to subtract H from both sides. So really I'm just going to rewrite my system as C equals 8 minus H. And then the other equation is still 225C plus 150H. Jade, I need you to stop. Is equal 215.75. Okay. So then now I'm going to replace the C in this equation with the 8 minus H, and I'm going to solve for C. So I'm going to have, here we'll do this in a different color, we'll do this in purple. So when I replace the C and actually start substitution, I'm going to have 225 times 8 minus H plus 150H equals 1575. I'm going to do some math rainbows by multiplying the 225 to 8 and the 225 to H. Julia, don't do that, please. And when I do that, I'm going to end up with 225 times 8, which is 18. So I'm going to end up with 18 minus 225H plus 150H equals 1575. Combining my terms, I'm going to have negative 225 plus 150. And that's going to be 75 or negative 75. So I'm going to have 18 minus 0.75 h equals 1575. I'm going to have to subtract 18 from both sides, and I'm not going to write that out, but you should understand that if I'm subtracting 18 from both sides, then I'm going to get 1575 minus 18, which is negative 225. Sorry, my thing's going crazy. All right, there we go. So then I have negative 0.75 h equals, and then when I just subtracted that 18 over, so now I have negative 2.25. And then I'm just going to divide. So I'm dividing h by negative 0.75. And then I'm going to divide negative 2.25 by negative 0.75. And when I do that, I get 3. So h is equal to, we'll even do this in a different color. Okay. So h is equal to 3. So remember, h represented hot cocoa, so that means he bought 3 cups of hot cocoa. And so this is easy math, but we are going to write out the steps. So in order to figure out C, like, yes, you probably know in your mind, well, obviously, then he bought 5 cups of coffee. But because I'm your math teacher, I'm going to make you write it out. So 8, again, completing substitution, 8 minus 3 equals 5. So then he bought 5 cups of coffee. So then the last step is just to write our answer as a solution. This shows that we understand what we actually did. Because yes, you got the right answer. You got h equals 3, and c equals 5. But do you know what that means? That's really what we're looking for as mathematicians. It's like, yeah, great, you applied this formula, but do you know what you did? Like, what does that actually mean in real life? And so what this means in real life is, again, looking back to the variable h. That means that Bobby bought 3 cups of hot cocoa, and he bought 5 cups of coffee. Sorry, guys, my daughter just had the biggest toot. Yeah, you farted. We know. Everybody knows now, Julia. And that is our solution. This next example, we're going to be doing the same thing. We're setting it up, solving for the system of linear inequalities, but this time we're going to be doing, we're going to be doing linear inequalities as it says. And the reason why we're choosing linear inequalities is because we're not looking for the exact amount. We're looking for just like the range of like ratio of t-shirts and shorts that she can buy that will still meet her goal of not spending more than $147. So we know from the example that t-shirts are going to cost $14 and shorts are $21. And again, she doesn't want to spend more than $147, and she wants to buy at least 5 items, which means she's not getting just 1 item. She's going to buy at least 5. So right now, we just need to start by writing our system of inequalities. So we're going to use kind of the same setup we used last time, but we're going to forego the table and just go straight into the equation. So the first thing I'm going to do is write my system for t-shirts, because I know she wants to buy t-shirts and shorts. So t-shirts I'm going to represent by T. So I know T plus, and then shorts will be S. So T plus S is going to be greater than or equal to 5, because she's buying at least 5, but possibly more than 5 items. So we're going to use that greater than or equal to 5. The next equation is for the cost, because remember, she has that cost constraint. She doesn't want to spend more than $147 on this stuff. So I know that t-shirts cost $14, so 14t plus, and again, the shorts are $21, so 21s. And this time, this has to be less than or equal to $147, because she cannot spend more than that. So that's why we're using the less than or equal to. So now that I have my system, I'm going to graph it. So there's a couple of ways I could graph this. I'm going to choose to graph the intercepts and then decide my shading based on that. So let's go ahead and graph the intercepts. So I'm just going to rewrite the equation, and we'll do this in different colors so that way you can see kind of the work for each one. So we'll have T plus S is bigger than or equal to 5. So that's our first system. And if I find the T intercept, and then for the T intercept, I'm plugging in 0 for S, and I'm going to have T is bigger than or equal to 5. So the t-intercept is going to be 0, 5. So hold on. I just did some mental math there. But again, remember, just to kind of write it out, be t plus 0 is bigger than or equal to 5. So then I know that t is going to be bigger than 5. Okay, and so then how I graph that, I would graph it as the intercept. So let's say t is like our x value, then I would graph it as the intercept 0, 5. Okay, that's really what that represents right there. And then to find the s-intercept, I'm going to just basically do the same thing, but with s. So s plus, or 0 plus s is bigger than or equal to 5. So then again, I'm graphing s is bigger than or equal to 5, which again is that intercept, but this time instead of being 0, 5 is going to be 5, 0. So now I have two equations that, or sorry, 2 points that I can graph. I have my intercepts for this particular equation. So I'm going to go ahead and do that using the same colors. So I know that the first equation, t plus s is bigger than or equal to 5, has an intercept at 5. And another intercept over here at 5. And then right now, I know it's going to be a solid line because for both of these lines, because they have a line underneath the inequality. So I'm just going to draw the line, and I'm going to worry about the shading after I have both my lines drawn, just because I'm working in Kami. So if I go ahead and color everything, it's not going to be very pleasing. So that's my first equation. The next equation is 14t plus 21s equals 147. So I need to find the intercepts of that equation. Again, you could put it into y equals mx plus b form, but since it's in standard form, I just find it easier to go ahead and write it as y equals mx plus b. Okay, so for this one, let's go ahead and let's plug in 0 for s. When I plug in 0 for s, it should be working. There we go. I'm going to have 14t is, there we go, less than or equal to 147. Divide by 14 on both sides. T is going to be less than or equal to, this is one I can't do on top of my head, 10.5. Okay, so my first intercept point, we'll say this is the y-intercept, is at 0, 5. Or 10.5, sorry. I was looking at the other one. And then the s-intercept. S is shirts, remember? For shorts. So then now I'm plugging in 0 for t. So then I'm just going to have 21s is less than or equal to 147. Divide by 21. S is going to be less than or equal to 7. That's an easy one. So I got my, which corresponds to the point in this case. We're going to say it corresponds to, come on, man, you can do this. It really wants to highlight today. There we go. It's going to correspond to the 0.70. Parentheses around that bad boy. Okay, so then now I have something to graph for my blue equation. So my blue equation, again, going to my drawing tool. This time we're choosing blue. So my t-intercept is at 0, 10.5, which is going to be right there. And my shirt intercept is going to be at 7. Okay. So then now I'm going to draw, again, a straight line because there's a line underneath that inequality to connect my dots. Okay, so remember the solution to this system is where there's these intersections, where the colors are going to overlap. So I really, for s is bigger than or equal to 5, or if we look at the first equation, t plus s is bigger than or equal to 5, I'm going to be shading above that. So I know that my solution area is going to be above this line right here. And then if I also, so here, let's just put a dot there to kind of know that we're going to be shading purple. So I'm shading above in this area. So ideally the solution area should be here, but we just got to check with the blue line. The blue line, I want all the t values that are less than 100, are less than 10.5, which again happens to be below this line as well. So below the blue line. So if I shade in between there, so let's go ahead and get our color tool out. We'll shade our solution as green, green for go. We'll make it bigger so that way I don't have to do this forever. Then this area right here, the in between the two lines, effectively is my solution. So what that means is that basically I can choose any point that's in this area, and that's going to represent the amount of t-shirts and shirts that I could possibly buy to meet the goal. So like, for example, let's just choose a random point. I'm going to make it smaller. Let's say I want to choose something in the middle right there. I'm going to choose that point. That is the point 26. So again, let's go ahead. We didn't do this first, but we should have. Let's go ahead and label this. Remember this part right here. Sorry, this represents the amount of shorts. And this axis right here represents the amount of t-shirts. Sorry, t-shirts. Sorry. So if I have this point, then that means that I could buy, or Gracie could buy 2 shorts and 6 t-shirts, and that could could be a possible combination that she would have. So 2 shorts and 6 t-shirts. So 2 times 14 plus 6 times 21. Is that less than 147? Yes, it is. So this is just one way. So this just what this models is all of the examples. We wanted to find out what the maximum was. Then that would be a different. That's when we would use regular system, because we just want to see all the possible situations that she could have. This system's going to work.